Hey guys, great to see some people dripping in. There's always this, and you always do, so I'm very grateful for that. Thank you for joining us this evening. For anyone who doesn't know me, and I hope there aren't many of you, but if you don't know me, I'm Kerrin Grosvenor. I work for Betfair in Australia. I head up our automation team. So our job is to help make automation, historical data and modelling more accessible to more people in our target audiences, which is basically all of you. I'm glad you're able to join us tonight. I'm sorry that in part that's because most of us are in lockdown again. And it's a shame that we can't do this in person, but let's make the best of what we've got. And at least at the moment, that means that we're here with the group of people who are interested and hopefully have a slightly more interesting Wednesday evening than you'd have otherwise. So yeah, thanks for taking the space and joining us this evening. So I'm going to do my bit of preamble and then we'll get Tom on here because I know he's the interesting part. But as my intro, so why are we here? Why are we investing our time and effort in this? So from my perspective, I've been with Betfair 4 and a bit years, been in this space about 3. And for me, so much of what the value that we bring as an automation team is in helping people to share their learnings and knowledge with each other and help to create connections, because at the end of the day, a lot of what we do in this space is pretty complicated, right? And the more we have an opportunity to share and learn from each other, the easier the journey is for those people who are new to it. And also having people to share that journey with makes it less intimidating and just a bit more fun. So, you know, Betfair, our motto is to create more winners. So that's why we're here, to help you guys win more and to be more of you in the space who are winning. So in short, that's why we're here. So tonight, what are we here for tonight? So Tom has written a really cool tutorial, which Ivan will share in the chat. Oh, hi, Ivan. Ivan's new to our team. This is week 2 with us. I haven't got to meet him in person yet, but eventually I will. So if you see him on Slack, please say hi to Ivan. But Ivan's just sharing a link in the chat. This is to the tutorial that Tom's written. So what we're talking about tonight are automated betting angles. So it's hard to find the right title here, but basically what we're talking about is those edges that people talk about. You know, what relevance is the home ground advantage? When X jockey rides on X track over X length, or they're always underrated. You know, these things that you might have as an opinion without necessarily having the modeling skills to build, you know, a statistical model to derive those edges. What can you think of yourself? And then how can you test that to see whether this theory actually holds up in reality? And then how might you implement that? So Tom's put together a tutorial with sort of different levels of complexity, from more simple to more complicated approaches to checking some of these angles out. And the idea here is, you know, if jumping to building your own model is a bit too much of a first step, maybe this is a bit more accessible as a step in that progression. So really grateful to Tom for coming and doing that. Through the evening, we'll have the chat function turned off, but the QA function turned on. So if you've got questions, pop them in the Q&A box as we go. If you want to chat with people, I suggest you go over to the Quants Slack group and join the conversation there. It's a really engaging community, really active, some great people who are really open to sharing their experiences and learnings and being that community that a lot of us lack. So if you're interested, thanks, Ivan. Ivan's just shared the link down there. So yeah, go join, find the meetups channel and join the conversation there. If you're watching this afterwards, or if there's anything more widely that we can help out with along the way, suggest hitting us up at automation@betfair.com.au. That'll come to me and Ben and Ivan, and we'll help you out as much as we can. And Ivan will share that as well. Otherwise, without further ado, Ben, do you want to get Tom's camera on? So a very short intro to Tom. Tom and I go back quite a few years now. Tom used to work at Betfair in our data science team and is now moved on to do some of his own stuff. And Tom didn't come from wagering background, didn't know much about racing or greys or some funny conversations we've had over the years, but now knows a lot more than you used to. Tom, over to you for a bit more of your intro to yourself. But thanks for joining. I do appreciate it, especially this time of night.
Yeah, hi. That's okay. So my background is kind of like, is not wagering. It's more sort of just like the technical side, sort of the analytical side, I guess. But then I worked in wagering at Betfair with Kerrin. And that sort of got me interested in the space. I've always been a little bit interested in betting, but not necessarily quantitatively. And then sort of having the exposure to the quantitative side, seeing sort of how customers do it and seeing how the wagering operators do it and stuff like that got me interested in it. And then since that role, I've sort of been doing a bunch of different stuff, including developing sort of wagering models to sort of bet for me.
Cool. Nice summary. Much better than mine. And I love that you're prepared to sort of go through it and share bits of your learnings, and that you see that there is value in that to sort of share
I think so. I think like it's a bit of a weird space where like there's lots of sort of recreational people, and there's lots of like non-quantitative people, and there's also some quantitative people, and then there's also like some very quantitative people who are very secretive. So it's like a bit of a weird space where like if you're kind of like from my background, it's hard to see where you fit in. Or if you're sort of like in a space sort of similar to me, it's hard to see where you fit in. It's good to provide the perspective for people to sort of like as a bit of a starting point for like where you want to go and like how to deal with these data sets and how to think about these various things. I think it's
sort of a bit like just knowing what the map looks like, right? Like one of the analogies I use is, it's a bit like when you're playing one of those old PlayStation games. Been decades since I played on those, but the ones that had the map where you had to explore the terrain and everything's a bit misty. That's how I feel that a lot of this space is. And you've got to kind of like explore and figure out which way you should be going, and then you go backwards because you went the wrong direction. And that part of what we can do by sharing a bit more is to know a bit more what that map looks like. It doesn't get you to the place on the map, but at least you might know which way to go. Yeah, for sure. That's how I see it.
So I wrote I did a different session on sort of using historical odds data to backtest like a fundamental model. And now I've written one that's sort of like a little bit of a different application on how you can use this historical model for a sort of a different betting application. And each of those things is sort of like, it's not necessarily like this is the approach you would do to backtest your model. Like these are the betting angles that I would recommend you use. It's sort of like, it is that sort of first step to sort of get you thinking about like, that's something that I'm capable of. That's something that I'm interested in. I can see where I can take this. A bit of a recipe.
How you might go about it, right?
Yeah.
Otherwise it feels like a bit of a black box of, well, here's the data, I've got this vague thought in my head, but how do I turn that thought in my head into some sort of, formula or function that I can then look at this mess of data and turn it into something that means something. And I think for me, that's the value in what you've put together here. Something that most people who have some analytical bent, if you can play with Excel and you can get your head around functions and formulas in Excel, you can probably follow along most of what you've put together here, at least to that beginner to intermediate level. That's how I feel about it. So hopefully that's accessible to people.
I think like it's relevant for the group of people like you described that are sort of like good Excel users that sort of know how to use formulas and stuff like that, all the way to the people who are like maybe just no programming, but like just sort of like not able to sort of build like robust predictive models. Like they want to apply their quantitative skills to sort of wagering, and they have some quantitative skills, but like maybe they're not like willing to undergo the task of like building a bottom-up fundamental model. It's like, how can I get some bets down? How can I do some analysis, and how can I have some fun with it?
And also, in terms of things like learning, programming and so on, we've talked about this before. It's a really good theory to tell someone to go and learn to program, but actually doing that is actually quite complicated. As much as anything, following along with some, how to learn Python,
Yeah.
course online, you'll follow it all and you might even get good marks, but at the end of it, you haven't learned much.
Yeah.
Whereas if you've got something that you're trying to achieve, i.e. this, you can learn a lot more in that process, which might then put you in a better position to apply those skills to the beginning of maybe a qualitative model. I think that's part of how I see it anyway.
Yeah.
But tonight, so do you want to share your screen? I know you've got a bit of a slide deck to take us through. And I will let you take lead, and I'll butt in as I do and ask questions.
For sure. Is that working?
Yes, I have got that. Thank you.
Yeah, so I've got a couple of slides, and then also the link to this article is being posted, and this is sort of like a big long article with lots of code in it and stuff like that. I won't necessarily go through a lot of code, but I'll sort of point to a few things and discuss a few things. But I'll start with the slides, which I can present somehow. Present. Okay, so I sort of discussed this a little bit. Data scientist with some experience with wagering. I'm a big R guy, but for these sort of articles that I've written, I've sort of been honing my Python skills.
I.e. pushed into Python.
Yeah. And that's mainly because it's a little bit more popular for people trying to do this kind of stuff. And also Betfair Lightweight is a really powerful library to get you working with the historical string data.
Yeah, which it doesn't have quite the same functionality.
No, definitely doesn't. So I'm writing a few articles. The last one was about backtesting, and this one's about sort of betting angles, and that's the link to it. So KJ sort of described a little bit about what I'm talking about here, but I think everyone knows what this is. As sports and racing fans, you're going to hear these kinds of things all the time about these kind of claims about how you can make money from betting. So things like laying an NBA team playing on the second night of a back-to-back. Everyone always talks about betting unders for the total points in an AFL match if it's raining or it has rained. Or you can win money just by backing horses that are trained out of certain stables and stuff like that. You hear lots of stuff, lots of claims from people, generally non-quantitative people, about these kinds of trends or profitable angles that you can sort of use in your betting. But generally these things aren't evidence-based, or they've been baked into the odds like a decade ago, and you're not going to find any advantage there. But something that I learned when I was working for Betfair is that it is possible to bet like this and be successful. There are lots of people on Betfair who sort of make a living out of doing this. And it's not necessarily like they have extremely sophisticated machine learning models that are sort of just way sharper than the wisdom of the crowd, and they've got an edge that way. They just have a bunch of discrete advantages or edges or angles on the market that they've found and they've been able to profit off for a long period of time. And it's especially enticing if you find these angles that are automatable. So you can find them, you can analyze them, and then you can implement them, and then move on to the next thing. But to do so, you need to sort of be creative. Like I said, lots of these sort of simple angles, these things that are sort of genuinely sort of facets of the game and race code that we're talking about. So total scores are lower in raining conditions and stuff like that. That's actually a fact of an AFL match. But many people have tried to make money off these kinds of things way before you have. So to find ones that haven't already been baked into the odds, you need to sort of be creative.
Think outside
and then sorry?
Think outside the square a little bit, right?
Yeah. And I don't want that to sound like you're not going to be able to find one unless you're completely outside of the square. Maybe you just combine a couple of variables or a couple of data sources that people haven't done before, or maybe you dig into something a little bit more specifically than people have done before, or maybe you take advantage of the edge at a scale that someone hasn't done before. But yeah, you sort of need to do something that someone hasn't already figured out. And then to implement them, you need some basic programming skills, or you can use sort of a third-party tool if you're sort of an Excel user and you're doing most of this analysis in Excel. But if you've sort of got basic programming skills, to do this in Python, you don't need to know that much. You sort of just need to know how to use pandas and do some basic data manipulation. And then you need to be able to sort of use the Betfair API through Betfair Lightweight, and that's not that hard either. So it's like, it's not that far away if you have some basic programming skills to be able to do this. And I try and outline an approach you can use applying it to thoroughbred racing, given that we're coming into the spring carnival.
It's nice to be able to have something where you can sort of, that whole implement, refine, iterate process is much easier when, there are 100 races a day.
Yeah.
Compared to some OKFL, we get, a few matches a week.
Yeah,
so
that's for sure. Like, yeah, if you find an edge on NFL, it's like you can take advantage of it maybe 16 times a year, Yeah. So yeah, that's something definitely that I learned about wagering, is that like if you can do things in racing codes where you can realize your edge hundreds of times a day, it's definitely preferable to doing something that only happens 16 times a year. So what can go wrong? So I just went to a betting site. I won't say which one, but this is a recommended bet on a popular betting site that says the Suns are 6-70 since 2012 when an underdog of more than 5 goals, covering at just 45%. They've covered 4 of their last 13. And then it says the Swans have covered 13 of 18 when favored by more than 5 goals. So this is something that sorry, I've put here, this is a bit of a popular NBA meme, if you're an NBA fan, where this graphic went up on an NBA game a few years ago, where it says, it basically like, it defines these arbitrary stat cutoffs, and says that like Thaddeus Young, you might have heard of a lot of these other basketball players, but Thaddeus Young is sort of like a mid-tier power forward of the last decade. That if you sort of like cut their splits in such a way, 13.5 points and 5.9 rebounds exactly, and 1.4 steals, 49% from the field and 30% from three. Thad Young's like only one of 5 players who have been able to do that, and the other 4 are sort of Hall of Famers.
Even I've heard of them, which is like
yeah. And like obviously the point of this meme is that you can sort of like create arbitrary stat cutoffs to like support any sort of narrative that you have.
It's what the media does every day, right? To get us headlines.
Yeah.
The first time X, Y, or Z, even though that X, Y, or Z is really arbitrary.
Yeah, so if you define some sort of like ultra specific arbitrary definition of something that's important, it's like lots of people can eat it. Or like if you like, what they would have done is they would have filtered on Thad Young's exact stat line, and then looked back historically at the people who've done that. And obviously like the way the data works, if you do something like that, you're going to sort of like overfit to some kind of narrative that you have. And a similar thing's happening here in this sort of like, this is what we're talking about in betting angles, where you sort of like, if Gold Coast is an underdog by more than 45, by more than 5 goals, can I take advantage of it somehow? Is there some kind of trend that I can take advantage of? And most sort of like data literate people would look at that and say that that's nonsensical. It's describing a team that's gone back since 2012, which is comprised of 22 individual players who are different every year. Why would there be some trend that exists for that collection of different players every year? And you've also you've done something similar to this NBA meme, where you're just sort of like deciding on some sort of arbitrary cutoffs and stuff like that. It looks all very like over-engineered and overfitted. So that's an example of like betting angles that you see a lot in gambling media. And so that's how you can sort of go wrong. And that's why you can sort of be put off by them, because they seem a little bit sort of stupid and like data literate. unnumerate. But there's actually like a way that you can go about it, which a bit of a recipe which can sort of correct for some of these things. So that's what I'm going to try and go through.
Nice.
So angles or models. So this is another thing that I thought would be good about this article is that I think there's a little bit of confusion in sort of online content about quantitative gambling strategies, about building models versus an approach like this. I think like a lot of times what people are going to sort of modeling resources, and often what they're presented is this kind of thing, and vice versa. A lot of times when people are kind of like thinking about implementing strategies or quantitative approaches to betting, a lot of times what they've seen and heard are these kind of like things that they get presented in gambling media and things that they have ideas for and they want to hypothesize for and test for. But the people that they go to are talking about like building fundamental models. So I think that there's sort of like two communities of people there and two levels of capability, and two different ways that you can leverage quantitative skills in gambling markets. But yeah, they're two different languages. And sort of, I'll give you my opinions about the pros and cons of each. I'm someone who doesn't do a lot of this and does like mostly fundamental modeling, but it's not necessarily all that it's cracked up to be in that space either. So some of the pros and cons, the speed to market on approaches like this is just way smaller. So like if you're going down the path of fundamental bottom-up modeling, it's going to take you a huge amount of effort. It's going to be like probably not on your first 50 models that you built for a particular kind of domain. It'll be like at your 100th model that you get to the point where you're confident that you've found a model that's better than break even. Whereas an approach like this is a lot simpler, involves a lot less data, a lot less assumptions, a lot less sort of massaging. So you can sort of get things done pretty quickly, and you can sort of implement them and start testing them and stuff like that. Maintenance, these kinds of things, they have less inputs, they're less complex, they're less convoluted. So like maintaining them and like tweaking them and stuff like that is a lot easier than a fundamental model. And like I said, difficulty, like it's probably the hard truth, but like if you want to sort of build a successful fundamental bottom-up model, you probably need to have good modeling skills already. It's not enough to sort of just copy the boilerplate image classification code that you find on some machine learning package website or something like that. It really requires sort of like closer to the Kaggle level machine learning skill than the sort of like the boilerplate beginner stuff. And I think that that's sort of like a little bit of a trap that a lot of people fall into, is that they know enough to build like your first basic hello world machine learning model. And so they think that they can build a profitable fundamental bottom-up model. But really it's quite a few levels beyond that. And I think if a lot of people knew that, they would maybe want to start somewhere else. They want to start somewhere here, more like this, where you can make some money maybe and like do a lot more iteration and get some results faster and stuff like that. If you knew how much of a big challenge it was, possibly you might choose something like this. But on the other hand, that kind of approach, if you do succeed, it has much higher upside. These kinds of things are limited to like very niche angles, and maybe they sort of dissipate in the market. Maybe you can't find as many to exploit. You can only find a few a day or a few a week or something like that.
Paul put in a question about that, and I think you've spoken to it there, but his question was, do you find this sort of analysis has a shorter lifespan than a model through that fundamental bottom up? And often it's going to be the whole fact that you can find it more simply means that other people can also find it more simply, right? And that's exactly right.
By definition, because the barriers to entry for you are lower, the barriers to entry for other people are lower as well. So definitely, but I definitely know that, that's definitely true. But I definitely know that, yeah, that's definitely true. But I definitely know that some people have been successful with similar kinds of angles for many, many years. So if you find sort of like a space which you're succeeding at very strongly with these sort of betting angles, I think that it can last for a long time.
Question on this one. Something we've talked about before, and I asked quite a lot of people about, is at which point do you, when you're looking at your historic results, when are you concerned that variance has gone from variance to a fundamental change, and you need to review your model because you don't have your edge anymore? Do you think, I haven't compared these two, but this is my gut, but do you think it would be quicker and easier to see where you've lost your edge here because there are less inputs, like you were saying, that there's less complexity in it, therefore is it easier to analyze and see when the market's likely to change? Or do you think that it's still just over X number of outcomes, it's going to take as long anyway? Do you have any
no, I think that there is some way in which it's a similar sort of problem where it's kind of like, you're just looking at your sample of bets and deciding, how likely is it that this performance is what I expected, and what I expected with one of these sort of approaches is sort of what you got in the back test, and at the same time, what you expect with a fundamental modeling approach is also the profitability you got in a back test. So in some senses, it's pretty similar, but there are definitely lots more failure modes for a fundamental approach where it could be something to do with your model, or it could be something to do with the market. Or it could be something to do with sort of the interplay between those two things. Or
one of your many inputs, that maybe there's a flaw in one of your inputs. If one of your feeds has changed fractionally or whatever, whereas this you've got most of these have relatively small numbers of inputs, right? Therefore, less complexity. Yeah,
that's what I'm saying. Like, so like with a fundamental model, you have more inputs. You're probably going to have more data sources and more complexity involved in sort of stitching them all together. And you've also got all the, reams and reams of code base that you've put into doing the development. And then you have, version control, and you have all kinds of different things that can go wrong. So there are definitely more failure modes. So definitely it's a little bit harder to sort of disentangle what's going on when you've got a fundamental model, and a little bit easier here where it's kind of like you've got some fixed thing that you think that you can take advantage of, and then eventually you'll be betting it to a point where eventually the results will start going against you in a way that is statistically significant. And if you use some kind of like rigorous way of assessing are these results completely different to what I expect, or is it just sort of random variance, then you should be able to detect that pretty easily. Whereas on the other side, like lots and lots of different things can go wrong when you're building a fundamental model.
I definitely agree. No, it's a good starting point to discuss the two.
So I'm going to go through a few examples with thoroughbred racing. So in terms of like what we need to do the task, like all betting analysis, we need historical odds. Again, I'm going to use the Betfair historical stream files. And this is the single best and most powerful place to source your historical odds data, because it's the most versatile and you can extract whatever you want, and you can, hopefully I'll give you a bit of an example of like a little bit more interesting data points that you can pull out of the stream. And then most betting angles will also include some reference data to the actual sport or racing code that you're betting on. So whether that's sort of like the weather conditions that the match took place in, where the game was played, what barrier did the horse run from, those kinds of things. You need to have some kind of like reference point to the actual race or the actual match to construct your angles historically. So for racing, there's actually a lot of good stuff that's available in the Betfair API. There's things like, the jockey, the trainer, the barrier, lots of different stuff like that you can get directly from the Betfair API. And if you can, it's best to try and like simplify your project in a way that like when you're implementing it, you always have to, when you're doing betting analysis like this, you always have to think about like what will happen when I implement it? How am I going to do this and I'm going to implement it? If you're doing something and you're pulling some data point that you won't have access to on the day, looking forward, then you might as well discard it, because you can't take advantage of it. You can't implement it.
So this is such an interesting one, Tom. Like, we've had some conversations internally about like what other data could we provide historically. You know, let's use weather as an example. Could we provide weather historically and marry it up with, to avoid a set of complexity for people, you know, to pull their own? And my response to this is always, I don't actually want to provide you with anything that you can't get in real time. So unless we're also going to start providing you weather in real time, I don't want to give it to you historically, because then it's like I'm setting you up for failure. You've got all this stuff historically, but then I can't give you the real stuff. And so that's, and
also, like, if you did that, it would need to be from exactly the same source, you know, like even if you were able to provide it on the day, it needs to be in exactly the same format and from exactly the same service. Otherwise, you're pulling something that's different to what you've done your historical analysis on. It's hard, but definitely it's helped me a lot, even in constructing my projects, to sort of think about it in terms of like, how can I construct my code in such a way that like, I'm basically simulating what will happen in the future, where like, it's like, I don't know anything that happened on that day. So can I just like cut off everything and like make sure that I'm not pulling anything that I wouldn't have access to on the day. It's a really important part of these sort of exercises.
Same as using BSP in your calculations when you don't have BSP.
Yeah.
Such a simple thing, but like, you know, we all do it, right?
Yeah.
One version of a model or another. Yeah.
Yeah, for sure. Yeah. So like I said, like for racing, Betfair API has a bunch of like of the good basic stuff. Again, like I was saying, in terms of being creative, like a lot of the angles that you can construct from these things maybe have sort of been baked into the odds already. So you might need to look elsewhere, but it's a really good place to start. If you're sort of like doing sports, or you're doing something where like there's not enough data in there, you may need to sort of join up the API feed to some other secondary data source. That might be from GitHub repos or scraping websites or premium data subscriptions or something like that. But again, you need to make sure that like whatever you're getting historically, you'll have access to on the day. In terms of the odds, so I went through this in the last one, but there are sort of like 4 main ways that you can get historical odds. You can sort of collect your own odds. You can look at these historical BSP files. You can mine the Betfair historical odds stream data, or you can ask Betfair if you're a VIP. They can sort of cut you up some custom data yourself. But the Betfair stream data is definitely the way to go. And hopefully some of the articles that are going up on the Automation Hub should be a good start for you if you're a Python user. But the files are huge. And you know, even with a lot of compute resources, the extraction is really slow. So you really got to think about, in the context of a task like this, you need to think about it in terms of like a workflow where you sort of like, you have some hypothesis, you decide what data you want to extract for that hypothesis, and then you test the hypothesis. And then if it doesn't produce the results you want to, you have to go back and like get more data from the stream, or tweak the data that you're getting from the stream or something like that. It's not feasible to just sort of like pull out all the, even if you normalize it in a way that your tools can use, you can't just pull out all the data and chuck it into a tool, because you'll run out of RAM or run out of like compute straight away. So it needs to be this sort of life cycle.
Yeah, using the approach we're taking here, like, you know, if you're further up that dev stream and you're someone who's, you know, got some comfort with multi-threading and you know, having an approach like that, or you're happy to work in a different language, like there are much faster languages that can play with this on the fly. And you know, I've run my own sims where I do just keep going over and over it, and it's not fast, but it's phenomenally fast compared to Python. But you know, the reason we stuck at this point, right, is that if you can do that, you're probably beyond this tutorial. So
exactly,
yes, if you can go up that end, you can get it fast. But where we're at here, you're 100% right. You're sort of making that judgment of how much data do I pull to avoid having to pull it again and again, right?
Yeah. And that's the advantage of the stream files, is that like normally what people do is like, the majority of people do who have VLPs already, they go like, hey, Betfair, can you provide me this file? And I want these columns, and these are the things I'm going to analyze. And then when it doesn't work out, it's kind of like, ah, shit, I have to ask them again, and maybe it'll take a month again. If you can sort of just work on a code base and sort of run your extraction yourself, then it's kind of, you can run this process of like going back to the odds files to try and extract more information. So just to give you an example, what I'm talking about is like, I'm interested to create some angles on thoroughbreds betting at the BSP. I want to include some indication of like price momentum or market support in some of my angles. And maybe I want to test some back to lay strategies. So I want to pull some information about each runner's in-play trading. So my initial hypothesis was I want to extract the BSP, the last traded price, sort of some idea of volume weighted average price 5 minutes before the scheduled jump, the same thing 30 seconds before the scheduled jump, just the volume traded on the selection, and then I'm going to extract sort of like the lowest traded price in play for each selection to give an idea of like what that runner's in play odds reduced to give me an idea of what I could lay out for. So like I was saying, in terms of like the Betfair API, the list market catalog, runner metadata inside list market catalog has a lot of good stuff for racing. So it includes things like trainer, jockey, horse's age, class rating, a few other things. You go to the Betfair API docs, it'll tell you all the things that it includes, but there's lots of good stuff in there. The problem is that the historical stream files don't include this chunk of data, so we aren't able to extract it when we collated the odds. We know we have access to it when we use the API live. So we're just going to take things. We're going to go to this API endpoint, which KG has posted a couple of times, which is sort of the back end to the hub ratings. We know we'll have access to it on the day, but we're able to historically extract it from these API endpoints.
It goes back quite a long way. The only thing I always have to say with this is unsupported. Someday, if my plans go the way that they should, we'll get a nice, cool schmick version that is supported and has all the documentation, all this stuff. But at the moment, I keep having to say unsupported endpoint. It hasn't gone down yet. But
I mean, the majority of things you do in betting is scraping websites anyway. So like everything you do,
exactly.
It's just something that you have to deal with. So assuming we've got our odds and assuming we've got our race metadata, the code for both of those two things in terms of extracting these data points from the stream files, extracting some of these key sort of metadata characteristics for thoroughbred races from these API endpoints is in the article. I won't go through it, but assuming we have these two things, then I'm just going to run through like sort of a framework for like how I would go about coming up with betting angles, having these two pieces of data. And then I'll go through some examples. So I'm saying there's like 3 ingredients to creating a betting angle, in my opinion. So the first one is sort of variable chunking. So with betting, you're always battling with drawing conclusions from small sample sizes. So to get more robust angles with more robust profitability estimates, it's helpful to sort of use your domain knowledge to chunk variables into conceptually sort of similar groups. So like this is where your domain knowledge really comes in. So the idea that like horses running from barriers 1, 2, and 3 present similar sort of race dynamics for a horse or a jockey to one another. So you could use the barrier number in your angle construction and sort of create some kind of like angle where it's like I back barrier 2 at Flemington, over this distance or whatever like that. But conceptually, that if a horse is running from barriers 1, 2, or 3, it's sort of like a similar kind of race dynamic. And if you can sort of chunk variables up into bigger groups, you're going to get a more robust idea of like, you're going to pull out more robust signals from the data.
You're not arbitrarily like constraining yourself, right? That, the difference between 1 and 3 is, as you're saying, for a runner might be negligible. And yes, you might be able to get to the same endpoint by having multiple different strategies that you end up pulling out, but that's a hell of a long way to get there, right?
Yeah, that's right. And like and you want to do it in such a way that you're not arbitrarily constraining yourself. So like if you found out that like barrier 3 was really good and barriers 2 and 1 weren't good, it's kind of like that's not a real signal. Like the fact that barrier 3 would just happen to be good in your historical set of data is not a real thing that you can map onto your understanding of how thoroughbred races work. Like if you are using your domain knowledge, it'll help. Doing this kind of chunking will help you like avoid overfitting to like just very small points that you see in your historical data. And the other thing is, so the second one is outer sample validation. And this is the most important one. So this is a technique that you use for predictive modeling where you basically like you slice off or hide at the very start of your analysis, you hide a big chunk of your data that you're going to not touch for the whole time. And then at the end, you're going to sort of use it to test your data. It's basically like saying like, if I had done this analysis, 3 months ago, imagine that I did that analysis and then I could use the last 3 months to actually test it and paper trade it instead of actually betting it. It gives you that ability to do that. And I think that that's sort of like where people generally fall down, is you can find signals in the data, even sort of statistically significant signals in the data over your development set and the historical data that you have your hands on that don't extend past the data that you have. So it'll prevent overfitting and it'll give you the most accurate estimation of expected profitability when you do begin to implement it.
And also probably save your bank balance.
Yeah, that's true.
In a very real way. Like, this is how many of these have you run where you've done this and when you get to the validation, it's wrong. And you could have done that in reality for 3 months.
It's like magic. It's honestly like magic how like you find some dynamic that on the data set that you do, and without fail, almost every single time, it's completely the opposite when you look at a new unseen set of data. It's actually quite crazy.
Yeah. So it saves you very real money. The biggest takeaway from this whole thing, if you can, right? Chuck it.
Yeah. And then the last thing is statistical significance. So I'll run through just a function that you can sort of take from the article and use it yourself. But basically, it draws from statistics. Obviously, we're dealing with sort of random variables and events and distributions and randomness and all this kind of stuff. So a lot of the techniques that come from statistics are really well suited to wagering sort of analytics. So this is a technique where you can basically quantify the likelihood that the results you're seeing are a trend, are a real phenomenon, and not something that's just happened by chance. So I think it's probably best that I'll run through the example of that, but it's another sort of tool in your toolkit. So these are my 3 ingredients. So now I'll just go through the 3 examples that I have. So this is the article. So there's lots of discussion about a lot of these different things. Here's the code to extract stuff from the stream data. Here's the code that you can use to extract stuff from that Betfair API endpoint. Here's sort of like the assembly of the data. You can have a look at sort of what I've pulled from the stream file. So we're at 5 minutes out, 30 seconds out, BSB, last traded price, traded volume, the minimum in play for the lay. And this is the stuff that I've got from that Betfair API endpoint. So things like weather, track condition, race distance, barrier, trainer, jockey, weight, those kinds of things. So here's where I discuss the methodology that I sort of just laid out on those 3 slides. So in this case, the chunk, I'm just going to go through, again, like I said, this isn't like, these aren't the angles that you should try and do yourself. These are just sort of an example of how you could go about doing it yourself. So I sort of like have decided that I'm going to think about distance and barrier group for thoroughbred racing. So I don't know much about thoroughbred racing, but I know that like the races get run over lots of distances, like 800 meters, 810 meters, 850 meters, blah, blah, blah. Using my knowledge, my limited knowledge of thoroughbred racing, I know that those are very short races for a horse. So I can sort of group them into like, I just did a bit of a histogram of distance and pulled out sort of 4 key sort of points that I can use, where like under 1100 is sort of sprint races, under 1400, there's a fair chunk of races there that I'm going to call mid-short races, and then under 1800, I'm going to call mid to long, and then anything over that I'm going to call long. And similarly, just doing a bit of a histogram on barrier, I can see that like if I want to split it to like inside midfield and outside runners, I can sort of split it at barrier 4 and 9. So I can use those two chunking functions to sort of apply a bit of a mapping from distance and barrier to these ideas of distance and barrier group. In this analysis, I'm just going to split out, I'm going to do my train and test on dates. So I'm just pulling out anything that happened after April. My entire set goes from July to June, July to July, I think. So anything after April, I'm going to call my test, and then anything before, I'm going to call my training. So a lot of the analysis that I do is just going to be based on the train set. And then right at the end, I'm going to go, okay, like apply this angle to the test set and see what my profitability would have done. So none of my hypothesis testing is getting contaminated with things that happen in the test data, things that happen outside of the training set. So this is a bit of a discussion about statistically measuring profit. So a lot of times you'll hear like a jockey has a profit on turnover of a certain amount over its last 50 races or something like that, or like this horse is, you know, profit on turnover is, you know, 7% over its last 10 runs or something like that. So just like sort of splitting, doing a back profit on turnover for the horses in my training set, you can see that like, you can see what the problem is here. Like you can get a 275% pot by betting on this one horse. And you can see that like, obviously like this horse has run once and it ran at a BSB of 275 or something, and it happened to win. And you know, intuitively, even as a non-analytical gambler, you know that that's not any kind of trend. It just happened to win. It's just randomness. So the way that you can sort of control for that is to use this idea of statistical significance, where like if you treat your bets as sort of like binomial outcomes in terms of a probability, and you have a number of bets and you have the odds at which you're betting on them, you can sort of use a statistical significance test to sort of measure how likely the results you are seeing in your historical data are from randomness or an actual trend. And basically what it does is it just says like statistical tests, normally they just have some idea of like a null, it's called a null hypothesis, which is like assume that no effect, assume that you don't have a profitable edge, assume that you don't have a horse which is producing your profitable expected value. And then it creates some quantification of like the results you actually saw, whether it be huge profit or huge loss or whatever, how likely are they to have occurred, assuming that that it is just a zero expected value bet for that horse. And if you have a low probability that it was caused by chance, then you have a low p-value, and that's when you start hearing about things like a p-value under 0.5, which is just an arbitrary level of confidence that you want to assume that the results you've got are a real trend and not just randomness.
So Paul's question is, what p-value do you use as your cutoff for statistical significance?
I mean, I don't really use it as like a sort of black and white input. Like I wouldn't just go like, you know, any sort of strategy I have, which is some level of p-value, like I'm happy with or whatever.
So more a finger in the air sense.
Yeah, it's more just like
what you're looking at.
It's like a metric that goes into your suite of metrics that helps you make decisions. Because yeah, like people point out that like the threshold is just an arbitrary decision. You know, there's nothing special about, like this meme suggests, wherever the meme is.
I didn't end up putting that in here. I wasn't as brave as you.
You cut it out. Like the meme suggests, it's just
Sorry,
arbitrary.
it's in the original.
it's just an arbitrary cutoff. So yeah, it's like, you know, a 95% significance is good. You know, 99% significance is even better. But like when you start playing around with the data a little bit, you'll see that like even at a 99% significance, you can find things you're overfit, and you can find things that don't translate to your out of sample test. So yeah, I think like 95% is good, 99% is better, but it's not the only thing you need to be looking at.
Yeah. Very cool.
So yeah, so you can look at your you apply some idea of like a back and a lay profit. And then you can sort of test the results that you see. So here, what I've done is I've just applied a simple back and lay profit for all runners. And then I've grouped up by track, race distance, and barrier group, and calculated a total back PL and a total lay PL if you had have just backed or laid all the selections in those groups. And I have a number of times you've bet, which just assuming you're flat staking. This formula only works on flat staking, by the way, just so you know, and the average odds of those selections. And using these inputs in terms of your profit, the number of observations, the average odds, you can get an idea of like, you can produce a statistical significance. So putting our statistical significance lens on these things, so Albany, 1,000-meter races at Albany, the inside barriers, you can see that like backing has done better than laying over a two-horse sample at an average odds of 15. You know that that's probably not statistically significant, but this formula will give you an idea of that. So this basically says that, you know, only with 50%, I don't want to formulate the language of the p-value, but basically like that's a high value. So that's not a statistically significant profit. So it's probably one that you can discard on your historical data. So what I do basically is I sort by, I look at the lay value. So I'm looking at like profitable lay groups. So I'm looking at like track distances and barrier groups. And I'm looking at like the best p-value on the lay side. I take the top 5 and I produce I apply that logic on the train set and the test set. So I'm just getting a bit late here. I got to rush through it a little bit. But then I apply the logic for the top 5 lays on the train set. And that gives me a profit on turnover of 9% over my train set. And then I also apply that logic on the test set. And it turns out that this one has produced me profitable results on the test set, which suggests to me that I've looked historically, I've tested the statistical significance. It says that it's been a somewhat significant lay profit on these track barrier groups. And then I've used out of sample validation to test what I would have happened if I had have implemented that strategy on a test set, which hasn't been a part of my analysis so far. And it's also produced a profitable result. So that's not to say that I could just bet on these 5 track distance barrier groups and earn a profit of 8% going forward. But it definitely is a promising result to say that like potentially I found an angle which I can dig into a little bit more or implement at low stakes and see how I go. Similarly, the next one, basically I go through a bit of an example of like using market momentum on certain jockeys to see sort of like profitable combinations of market momentum and jockey. Basically what I say is for certain jockeys, if they've either been supported by the market, determined by if their price has moved in 5 minutes out from the jump to 30 seconds out from the jump, if that price is lower than it was at 5 minutes from the jump, that jockey has market support. And if I combine these things of like market support and jockey name and sort of back jockeys, depending on certain combinations of those things, can I produce a positive expected profit that way? So again, you've got to use your sort of domain knowledge to sort of think about why you would be doing this kind of thing. So my hypothesis about why this could be a factor is that a lot of recreational people bet off jockey name, and perhaps recreational money isn't a good indicator of how good the jockey is at riding these horses. Oftentimes it's based on small sample size or the last run that the jockey raced or some really bad memorable one that people have an idea of. So my thinking would be for that angle is that like recreational opinion on jockeys is maybe not a good is not a real indicator of like the jockey's performance. So maybe you can capitalize on that. So maybe under sort of market support, under market drift, if a jockey's getting laid a lot, maybe it's like they're getting overlaid because of some sort of spurious assessment that the public is doing about the jockey, or under market support, maybe it is a true signal that like this is a good jockey and it's been put on a likely winner, or maybe it's just a good jockey and can ride the horse as well and stuff like that. But yeah, it's really important to have that kind of like domain overlay where you actually think about the real world sort of significance of what you're describing. Like what is the angle describing, and how could you sort of map that onto an idea about how these races are getting run? It's not just some sort of like ultra specified version of the variables that you have in your data set. So similarly, this one as well, I found sort of like if you take the top 10 jockeys in terms of like market supported jockeys, you can produce a profitable result on the test set as well. And then finally, the last example I use is like, can you find some profitable back to lay angles in the historical data? So like I said, I was pulling out the minimum traded price in play for some horses. And if I could look at, things like horses that typically trade lower than their pre-play odds in play, or jockeys that typically trade lower than their pre-play odds but don't win very often. And that would be things that are basically like front runners in a race. So maybe jockeys like to sort of get out early and show strength, but generally they're on horses that don't win, or maybe it's horses that just like running really, they don't have a lot of stamina and they're really fast out of the gates. Maybe you can sort of take advantage of horses like that by backing them pre-play and then laying them off in play, knowing that like possibly they're not going to win, they're just sort of trading low because they're typically fast starters. And I do a bit of an analysis on that.
This is the sort of stuff where, we've talked about this before, like fundamental models, you don't necessarily need to know a lot about what you're modeling, right? If you've got the right approach, and we talked about this with Bruno, last month, that, he didn't know much about greys when he started modeling them. You didn't know much when you started modeling either, in terms of greyhounds. But this doesn't apply the same way to this sort of approach.
Yeah,
you do need to know a bit more about what you're betting on, so that you have some idea of what to test, right?
Yeah, for sure. And the creativity comes from the domain knowledge. I would suggest that like you probably do, like building a fundamental model, you're going to bump into the same things. And I've said this before, is like
it helps.
Your ceiling as a modeler is going to be constrained by sort of how creative you can be in coming up with features and coming up with different ways of transforming the data and stuff like that. So in similar ways, you kind of need to have some domain knowledge. But yeah, here, like the sort of the simple ones that you've heard before are probably have been exploited in the market already. So you need to sort of have some idea of how to sort of create these creative angles. So this last one, I basically I find a bit of a profitable combination of back delay strategies for certain jockeys. So I managed to find 3 profitable angles on my test set, just using my limited knowledge of thoroughbred racing and the few variables that I could extract from the Betfair API. And it's only 400 lines of code or something like that. So obviously these ones are probably not real and legitimate, and you should go out and bet them. But it gives you a bit of a recipe for thinking about how you'd come up with your own, and hopefully gives you a bit of a feel for like how realistic it is that you could create sort of like a profitable angle that you can maybe go and implement and see if it actually pays off in real life.
I think this is particularly relevant to people who, I think particularly racing, a lot of the guys in the community actually know racing really well, and can sit and watch markets and take quite a lot of sort of value from even just the way they're seeing the odds move. And if you can take some of that insight and articulate it like you have here into some sort of formulaic expression, it's interesting. I work with a lot of people, how many times there is value that you can derive from that, even off things that, like you said, could feel like a fairly simplistic approach. So I definitely recommend this as a play to understanding the markets better, understanding how you can automate into them better, and also improving your own skill set. up that, that curve that we talk about. I love this.
So this is my last slide. So I've just gone through sort of like a recipe for how I would do it, a couple of examples of how I've implemented that recipe, a couple of successful examples, or successful in theory. And then I sort of just want to give you a few pieces of advice from my perspective about the do's and don'ts of how you go about this. So I would generally avoid like odds-based angles unless you've got a really good justification. You see a lot of these like, betting in this odds range, or betting between 2 and 2.5 or something like that. If I back horses that are running, off a win and they're rated at this, it's kind of like, I can't really conceptualize how that would be any kind of real dynamic about how this next race is going to run or how this horse is going to run. There are examples that I could think about where like, that there could be some kind of like real life phenomenon that you're capturing by filtering on an odds range. But generally, I think that like they're probably examples of overfitting more often than not. Like I said in the statistical significance discussion, like things can look unquestionably significant or like really profitable in your test set. Just don't go too nuts when you start implementing them. Like it's just another level of confidence. Once you've got profitability in your test set, you have some confidence that it might be profitable when you implement it, but you shouldn't go too crazy when you start implementing it. It's probably, like we were just talking about in terms of like how quickly these things dissipate, it's probably not a set and forget thing. It's probably something you're going to have to review semi-regularly, every 3 months, every 6 months, something like that. And then, like I was talking about in the discussion of like the bad angles, like don't assume some kind of nonsensical level of continuity. Like a sporting team has done X over the last 5 years. Like a sporting team isn't an entity that plays. It's the combination of all its players.
Not a dog.
Yeah.
It's the reason we model greyhounds.
Yeah, that's right. Yeah. Yeah, so horses, well, greyhounds is a great example of that because it's not a combination of horses, the horse and the jockey. It is the same. The same thing is applied of players. Like players are pretty much who they are. And if you're betting props or something like that, you're betting on the player. And if you're betting on a team, you're betting on a combination of the players. So you can sort of build an idea of an angle based on the players in a team, but not on a team itself. It makes no sense. Do account for commission, so you can get like, the assumption here is why this is good is that like if you're betting at a BSP, you're betting at a fair price, you should expect to break even before commission. So it should be relatively easy to find things that win more than zero if you don't include commission, but it's that the thing that makes it hard is commission basically. So account for commission in your analysis. Try to sort of test theories rather than reverse engineer the theory that matches the observed data. I think I did a bit of a discussion of that, where like you come up with a theory, you hypothesize it, then you test it. Don't do too much of the like looking at the analysis, looking at the data and sort of like honing in on a particular thing and then going like, how could that be a real trend? Because you're really prone to, humans are very good storytellers. So you're really prone to like build the narrative before you can, for something that's just, it's not a real trend. So yeah, like I said, use your domain knowledge, try and diversify, think about different sort of angles, don't sort of like have too many that are sort of very similar. It's really like in modeling, like in everything in betting, try to think about ways you can combine inputs that other people wouldn't be using, because gambling markets are an extremely efficient way, or all markets actually are an extremely efficient way of like synthesizing all the available public information into a good estimate. So if you can find something that most people don't have access to, you're more likely to find something which is a real edge. And I've discussed this as well, which is like ensure the inputs you use for your historical analysis are exactly as you would have had them on the day in the past.
And that one's so hard, and it's a gotcha for so many people. People are very good at this, still sort of get you on the phone and go, I just did this stupid thing.
Yeah.
Don't feel bad because you will screw it up.
Sure. Yeah. And this is one of the hardest things, is this kind of idea of like leakage and how is this information that you're assuming that you haven't allowed to leak into your analysis? How has it done it in all these creative ways? Because there's trillions of different ways that it can happen in ways that you don't know how. So this is one of the biggest challenges you have to deal with. Yeah, so they're my do's and don'ts. A little bit over time, but if there's any questions, I'm happy to answer them too.
I do have a question here, and I think you spoke to it a little bit earlier, but you don't use a lot of this style of approach in most of your betting, do you? You have those modeling skills. You take that more fundamental modeling approach in most of what you do, right? That's more your end of the ballpark. This is more you trying to pull that down, I guess, for people to learn, as opposed to
this is something that I became aware of. Is one of the parts of my learning curve in the wagering space was kind of like understanding how, like, that kind of landscape of like seeing where people fit and stuff like that. Is that I assumed that people that did things like this, that bet on things like this, were betting on things that weren't real. They were betting on just overfitted small sample size notions of like how things work and stuff like that. And I only later in my journey realized that actually people do it in a sort of sensible and rigorous way. So I've definitely headed more down in the fundamental modeling side. And that gives me enough to work on. But if I was starting again, this is definitely something that I would try and do first, because it's really quick and you could get some quick wins and sort of maybe get some, wins enough to support your bankroll or something like that.
And I definitely see quite a number of people who go down this route who don't necessarily have the skills to do the back testing. And I'm hoping this will help, but who, with a little bit of support, can automate something that they know about the market and then kind of test live, which I never love as an approach, but sometimes it's what they want to do. And it's interesting how often that is that first serious step beyond automating someone else's ratings. This is often the first serious step in someone's sort of automation journey. And it's interesting how often they're profitable, which is great to see. I had a question here. Could you just go back to the very beginning, and in 2 or 3 sentences, can you just go back, first principles, what was your distinction between a betting angle and a betting model? Just go back. Now that we've gone through all this, how would you summarize each?
So it's the difference between a bottom-up and a top-down approach. So a fundamental model takes a whole bunch of information. You extract the market completely. Takes a whole bunch of information about a race or a sporting match, and tries to combine enough patterns and information and understand the dynamics of the game enough to arrive at a first principles fundamental estimate about the chances of a team or a horse winning the race. So that's sort of like the bottom-up approach, which is building the fundamental estimate of likelihood of winning, and then you compare that with the market and make a betting decision. A top-down approach is basically, it takes the odds as a starting point. You assume that the odds are efficient. You assume that there's sort of the wisdom of the crowd is really good. And then you try and find the things that haven't been accounted for. You try and find the things that maybe have been missed in the public making an assessment of what the chances are. If you can just find one or two, or a combination of two things that hasn't been perfectly included in the wisdom of the crowd, then you can, that's an angle. So it's it's instead of starting from hundreds of variables and going up to a fundamental probability, it's starting with the crowd's estimate of a fundamental probability and trying to find something, one or two things which haven't been included in that
they've missed.
Yeah.
No, I like that as a distinction, and if we could use that more widely in the nomenclature, it would make our life a bit easier. Do you have an opinion on which is better, or is it a bit of horses for courses stage?
Well, I mean, I like the fundamental modeling. It's a.
You're a data scientist.
Yeah, I like it. It definitely lots of pros and cons. It seems like the purest application of quantitative techniques is it's you versus the market. Like you come up with a better price than the market or something like that.
Yeah.
But definitely it has all the drawbacks that I described, where it's like, it's extremely difficult. It's extremely complex. It takes a really long time. Maintenance is a nightmare. You maybe never get there. Like there are lots of drawbacks. And then the top-down approach, it seems like a bit of an impure application of wagering. And you're going to run into things like the market's always moving underneath you. So like, how do you know if your edge is eroded and all this kind of stuff?
Yeah.
But it's definitely like, there are pros and cons to each. It depends on like what your skill set is, what you enjoy doing, what kind of like payoff distribution do you want? Do you want like no profit and then like a small chance at like a huge amount of profit, or do you want like a more reasonable chance at like having a good second income?
Side hustle versus an actual income versus
like your life's work kind of thing. So
money.
It's a bit of a different kind of it's pros and cons.
I have one last question before I know you have to head off to do bedtime duties, as do I. Last question. A question here. So it reads, seems to me some of this type of approach can be used for consumption within models. A bit like, for example, people might use the ratings from the hub as one of the features within their model, or the tips from XYZ commentator in their model. Is that something you've played around with at all or seen people do? I know some of the people in the quants community certainly do sort of use some of these approaches as features.
Yeah, for sure. I mean, like a lot of there is overlap in what you're doing here. Like I said, like you're trying to find one or two things that haven't been included in the market's assessment of the chances of a team or a horse or something like that. And in the same way, you're doing that in sort of a bottom-up approach, where you're trying to find the variables which sort of correlate to an outcome of your interest. So in that sense, you're doing a similar thing where you're trying to find the predictive power of a variable and comparing it to the market. I've always been a little bit like hesitant to, like I said, the drawbacks of a sort of a top-down approach is that like you're assuming the market is correct. So things can, like the market landscape can move underneath you, and you always have to be thinking about that. So I definitely have heard of people like putting them in predictive models and stuff like that. But the drawback of that is that it's just another thing, another input, which you have to be confident is the way that you've always thought it was, So if you're looking at, the horse's race time, for example, you have to be confident that it's recorded in the same way and it has the same distribution as what you used in your model development. It's just another one of those things where like whoever's producing this, whether it's sort of like a rated price in the hub or something like that, it's another thing whose methodology could change and whose distribution could change, and it's just another thing that you have to sort of maintain. So it probably adds more complexity to a bottom-up approach than I think would be more cost than benefit kind of thing.
Yeah, no, I definitely follow you there. Thank you so much, Tom. Thanks for the time for the tutorial, and for going through it, because I think the tutorial is really valuable, and I imagine a lot of people who are here now will go through and read it afterwards. But I think that the context and the narrative around it that you provide here is actually really valuable. So I really appreciate that. And you taking the time, particularly at this time of night. So thank you very much.
No worries. Yeah, and I rushed through the last 15 minutes. So if you're interested in this kind of thing, read the article, because there's some good discussion, and it probably explains the examples in a way that wasn't just completely rushed like I did.
No, yeah, definitely. And as always, you're always really kind with answering queries and things. So if people want to hit you up on Slack, I'm sure you'll be kind and respond to them. You always do. So I don't feel I'm asking extra of that. And guys, save the date. You'll have something hit your inbox shortly for our September meetup. So we're continuing our racing theme. It's coming into spring racing, and it's 85% of what you guys bet on. So it feels that fair that we should spend a little bit of time dedicated to racing. So save the date. We should have that out in the next week our meetup in September, which will be, as I said, spring racing focus. So watch this space. Otherwise, like we said, continue the conversation on Slack. Hit Tom up, hit me up if you've got queries or anything that we can help with along the way. Otherwise, I hope you all have a great night. Please stay safe in these crazy times. And thank you very much, Tom. I really appreciate that. And yeah, it's always a real pleasure.
No worries. Cheers.
Great. Bye, guys. See ya.